Hi everyone, welcome to another video lesson for Algebra 2. In this video lesson, you will learn how to solve quadratic functions by graphing. Okay, so this will be the introduction for most of you on how to solve quadratic equations. Before I go into the lesson, let me just remind you that the degree of the polynomial tells you how many solutions there are. Okay, so for example, the linear, you usually don't see a power, but if you don't see a power on the variable, that implies that it's a power of 1. Okay, so that means that this graph is only one solution. So if you solve this equation, you'll find only one solution. And again, keep in mind that this goes with the graph of the function. So when you graph the function, the line only crosses the x-axis at one point. But when you have a quadratic, however, a quadratic is degree 2, which means you should have two solutions. Okay, and as the degree increases, that whatever the power is, that's how many times the graph crosses the x-axis or could cross the x-axis. So you'll learn today, you'll be introduced soon to a number that you have not seen before, which is imaginary or complex numbers. But you'll see that in this unit. Okay, so this is degree 2. That means you have this function has two solutions. So with that said, don't forget solutions. It's the same as x-intercepts, roots, or zeros. So if you see any of those terms, understand they mean the same thing. So for example, this is the graph of a quadratic, which is a parabola. So it's possible that the graph will be crossing the x-axis at 2 points, which in this case we have two x-intercepts. Then it's also possible that the vertex is right on the x-axis, okay? And when it gets to that value, it bounces right off of it. So if that's the case, then that's a double solution because quadratics are supposed to have two solutions. So that will be a double. And then what happens if, when you solve the equation, you end up with a number that you don't know yet, okay? Which, like I said, we'll get there soon. Doesn't cross the x-axis at all. So the x and the y-axis are based on real numbers. So if it doesn't cross the x-axis, that means the solution has to be imaginary. But again, I'll get you there soon, okay? So I'm looking forward to this unit because you'll be introduced to complex numbers. With that said, let's do the next few examples. So for the following quadratics, graph then state the solution, 0, roots, or x-intercepts. Again, don't forget these terms mean the same thing. So what I am going to do is, since this function here is in vertex form, I'm going to notice that the vertex, okay, the coordinates of the vertex are where x is 3 and y is -1. So this is h and this is k. Don't forget that from vertex form quadratic. So I'm going to plot that point first. So 1, 2, 3, then down 1. This is the vertex point. From here, if you guys remember the table of values, you're taking the square, right? If I go left 1, 2, I'm taking the square of -2, which means I'm multiplying -2 times -2, which is +4. Meaning if I go left 2, up 1, 2, 3, and 4. If I go left 1, I'm taking the square of -1, which is -1 times -1, and that's +1. If I go right 1, 1 times 1 is 1. If I go right 2, 2 times 2 is 4. So we get the 5 points. And then I'm going to connect the points and sketch the graph. Then what I'm going to notice is I'm going to go back and notice where this graph crosses the x-axis. It crosses the x-axis at this point and this point. So then the x-intercepts, or the solutions, or the roots, or the zeros of this quadratic are where x is +2 and y is 0, and then the other is where x is 4 and y is 0. So these are the solutions, roots, x-intercepts, or zeros for this function. Okay, so that's example number 1. Example number 2, the vertex for this one is where x is -6 and y is -9. So I'm going to plot that point first. So this is 1, 2, 3, 4, 5, 6 down. 1, 2, 3, 4, 5, 6, 7, 8, 9. Right there. So we're running to our good friend 6, 7, right? Okay, so I'm going to go left 1, up 1, left 2, up 1, 2, 3, 4. Right 1, up 1, right 2, up 4. Then connect the points. And you know what? I'm going to keep going here because I want to see exactly where the graph crosses the x-axis. So then if I go left 1, 2, 3, then I go up -3 times -3 is +9. So then 1, 2, 3, 4, 5, oops, I lost track. Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9. There's one x-intercept, and then right 3 up 9. Then now let's connect the points, and we should be able to see where the graph crosses the x-axis exactly, right? You can see those points on the graph. So this is what we're looking for by graphing. So this is where x is negative 1, 2, 3. So negative 3 and 0 for y. And then this is 4, 5, 6, 7, 8, 9. So negative 9, comma, 0. So as you can see, we ran into your best friend 6, 7 in this problem 3 times. Right, number 3. So for example number 3, notice that we have a negative in front of it. So instead of the graph opening up, we're pointing upwards, going to point downwards. Okay, so the vertex point, the value of k is 0 and the value of h is negative 4. So then I'm going to plot that point. 1, 2, 3, 4. This is the vertex. And then this graph opens down. So if I go left 1, down 1. If I go left 1, 2, down 1, 2, 3, 4. Right 1, down 1. Right 2, down 4. Then connect the points. And notice this is an example of when you have the vertex right on the x-axis, which means that solution is a double solution. Okay, so I'm going to write that down. So the x-intercept is where x is negative 4, y is 0, and this solution is a double because we have the vertex right on top of the x-axis. Right, so that's number 3. Let's go to number 4. So for number 4, the vertex point is where x is 5 and y is 1. So let's plot that point first. So let's see, 1, 2, 3, 4, 5, up 1. And then from here, we have a 2 in front of the parentheses, which means we multiply the y values by 2. So if I go left 1, 2, I'm supposed to go up 4, but then multiply that 4 by 2. So then I go up 8, right? So 1, 2 to the left, up 1, 2, 3, 4, 5, 6, 7, 8. And there it is again, 6, 7. It keeps showing up. And if I go right 1, left 1, up 2. If I go right 1 up 2, if I go right 2 up 8. Okay, then I'm going to connect the points. And I want you to notice that this graph, notice that the vertex is not on the x-axis, and also the graph doesn't cross the x-axis. So then in this case, this is what's happening. Okay, it doesn't cross the x-axis at all. So this quadratic function has no real solutions. So it does have solutions, but the solutions are not real numbers. Okay, they're complex numbers, which again you have not seen yet, but you'll get to learn about those numbers in this unit. All right, next example. For the next example, we're going to use a calculator. Okay, and we're going to run our answers to the hundreds. So let's get a calculator. All right, so I'm going to enter this function in y equals. So it's x, let's see, x squared. So that's the square, and then minus x and minus 1. Okay, then I'm going to press graph. So I'm going to graph it. And we can see that this graph does cross the x-axis. So then I'm going to use a calculator by pressing second trace and then 0. So I'm going to press the second key. The trace key is this one here. And then I want to know the 0, which means where the graph crosses the x-axis. And notice there are 2 points. Okay, so, and then press enter. Now the calculator is asking me left bound. Left bound means before the graph crosses the x-axis, as you can see it here. So this is what it's asking me. What is the interval or neighborhood in which you want me to find the intersection? So this is the left bound on the calculator. Okay, so I'm gonna go before the intersection, before the crossing of the x-axis, and that should be close enough. Press enter, and then it wants me to get the right bound. So that means after the graph crosses the x-axis. So I'm going to get underneath or below the x-axis, and that should be close enough. Notice you have that interval here, and then I'm going to press I'm going to press enter again to get the interval. So it's asking me, okay, I'm going to find the intersection between these two values. So you see them as lines here. Okay, so then I'm going to press enter again, and then it says that the 0 is at negative 0.618. So since I'm being told to the nearest hundreds, that means 2 decimal places. So then I'm going to say that one intersection happens where x is negative let's see, 0.62, and y is 0. Okay, so that's one point of intersection. To get the other point of intersection, I'm going to press second trace again, and now I want the 0. So now I'm going to get to the other side of the graph. So before it crosses the x-axis, press enter. After it crosses the x-axis, so again, this is me telling the calculator, I want you to find the intersection in that neighborhood or those values. Okay, press enter again, and it gives me the 0 is 1.618. So I'm going to round that to 1.62. 1.62 comma 0. So this is where the graph crosses the x-axis. All right, so this is what I did. Okay, second trace 0, and then follow the prompts. So I'm going to do follow the prompts. Sorry. All right, so then the next one, let's go back to y equals. Let's enter this in this new function. So I'm going to clear the one I have from the previous problem, negative x squared plus 2x plus 4. Then graph it. Okay, so I'm not going to spend much time explaining how to do it here. So then I want the 0, so second trace 2. I want this intersection before it crosses the x-axis, press enter. After it crosses it, press enter again, and then press enter. And it says that that 0 is at 1.236, so I'm going to round that to 1.24, and it's negative 1.24. So negative 1.24 comma 0, and then let's get the other intersection. Second trace 2, and now let's get to the other intersection of the x-axis. So before it crosses the x-axis, then after it crosses the x-axis, press enter, and it gives me 3.236. So I'm going to round that 3 to a 4. So 3.24 comma 0, and there we have the two solutions for this quadratic. Okay, I'm going to do number 3. So for number 3, let's see, number 3, I'm going to go back to y equals, clear that function, and enter this one out. So this is 2x squared plus 6x plus 4. Then graph it. You can use this. You can also zoom in. Okay, to zoom in, zoom to and enter. So I'm going to get a closer look. I could do this with the second trace, but in case you want to use the zoom key, you can't, so you can see it more clearly. So let's zoom in. Okay, so zoom to, and then get to the vertex point, I guess, about there. Press enter, and it gets you a closer look. So as you can see, this will be useful whenever you can't tell if the graph intersects the x-axis at one point or 2 points. So then second trace 2, we want this intersection first. Okay, so let's see, and then press enter, and it gives me negative 2, 0. So then for this one, we have one intersection, negative 2, 0. That's 1 point of intersection. Then second trace again, 2. Now we want the other intersection. Okay, so that should be close enough to the intersection. Get above it or get above the x-axis, press enter and enter again. Negative 1, 0. So we have the intersections at negative 1 and 0 and negative 2 and 0. So these are the solutions, roots or x-intercepts for that quadratic. Okay, one last example. Go to y equals, and let's clear that function. And now enter this new one. Okay, so let's see, this one is x squared minus 4x plus 4. Then graph it. And I'm going to have to zoom out on this one. So then let's see, zoom, and we want zoom out, so 3. Then let's get to somewhere here. Okay, and then press enter. And let's see if that lets us see. There we go. Now I'm going to have to zoom back in. So zoom 2, and then get to the vertex point, because I want to see if that's just one intersection or two intersections. And it seems to be only one intersection, right? It's a double. So then second trace, we want the 0, so 2. And then let's get to before the graph turns. So this before it hits the x-axis and after it hits the x-axis. Press enter, and it gives us 1.99999, and it just continues. So if x equals 1.99999, then we can just say that x equals 2. So then the solution to this equation is 2 comma 0. And again, as we saw from the graph, this is a double solution because there is a bounce on the x-axis or off of the x-axis. And that's all for this lesson. Thank you for watching. Bye-bye.